Hello everyone, in this video we are going to learn about solenoidal and irrotational vector fields. So first we will define what is a solenoidal vector field and then the irrotational vector field. So solenoidal vector function is nothing but if the flux entering any element of space is the same as that of leaving, that is divergence of v vector equal to 0 everywhere, then such a point function is called as a vector, solenoidal vector function. Then irrotational is any motion in which the curl of the velocity vector is 0 is said to be irrotational. Otherwise it is rational. That is curl v vector will be equivalent to 0. So now let us start with the problem. Prove that divergence r power n r vector equal to n plus 3 into r power n. Hence show that r vector by r cube is solenoidal. So now we know what is divergence of r to the power n r vector, that is nothing but del dot product with r power n r vector. So this is nothing but, let me write everything in summation. So this will be summation I vector dot dou by dou x of r to the power n r vector. R vector is nothing but xi vector plus yj vector plus zk vector. So this is equivalent to summation. So when you take the dot product, this will give you dou by dou x of r to the power n into x. Similarly, you will be getting for all the other terms, but I am retaining everything in terms of summation. So this is equivalent to, so let us write everything fully. So this is dou by dou x of r power n into x, then plus dou by dou y of r power n into y plus dou by dou z of r power n into z. So now let us consider what dou by dou x of r power n into x. So here it is a product of two functions. So this is nothing but r power n into differentiation of x is nothing but 1. Then plus x times n r to the power n minus 1, and the differentiation of r is nothing but dou r by dou x. So we already learnt that how to find this dou r by dou x. Dou r by dou x is nothing but x by r. So this is r power n plus nx r power n minus 1 into x by r. So this is equivalent to r power n plus n x square r to the power n minus 1 divided by r, that we can bring it to the numerator. So this will become r to the power n minus 2. Similarly, you can get it for dou by dou y of r power n into y, and similarly for all the terms you can get. Therefore, del dot of r to the power n r vector is nothing but r power n plus n x square r to the power n minus 2, and for y it is r power n plus n y square r power n minus 2 plus r power n plus n z square r to the power n minus 2. So this is going to give you 3 r power n plus, here n into r power n minus 2 is common. If you take that outside, you will get x square plus y square plus z square. So x square plus y square plus z square is nothing but r square. So this is equivalent to 3 r power n plus n r power n minus 2 into r square. So this is equivalent to 3 r power n plus n into r power n. So r power n minus 2 and plus 2, these two will get cancelled and remaining r power n will be there. So this is nothing but r power n into 3 plus n. Okay. So the value of del dot r power n into r vector is equivalent to r power n times of 3 plus n. So after finding this, we have to show that r vector by r cube is solenoidal. So what is the definition of solenoidal? Del dot whatever the vector they are going to give, that will be equivalent to 0. So del dot of r vector divided by r cube equal to dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector dot product with r vector by r cube. That is r vector is nothing but xi vector plus yj vector plus zk vector divided by r to the power 3. So now this is equivalent to dou by dou x of x by r cube plus dou by dou y of, when you take the dot product, j dot j will be 1. So you will get y by r cube, and similarly you will get dou by dou z of z divided by r cube. Now let us consider the first term and we will simplify what is the answer for this term. Then similarly we can write for all the other terms. So consider dou by dou x of x by r cube. So this is equivalent to, here it is a numerator is also a function of x and denominator is also a function of x, y and z. So here we are supposed to apply the division rule. So it is v cube, that is r cube into differentiation of u, that is the differentiation of x is 1, minus x into differentiation of r cube is 3r square and the differentiation of r is dou r by dou x divided by r cube the whole power 3 whole square will give you r to the power 6. So this is equivalent to r cube minus 3x r square into dou r by dou x is nothing but x by r divided by r to the power 6. So this will give you r cube minus here 3x, 1 r will get cancelled. So this is 3x square into r. So this is 3x square into r divided by r to the power 6. Okay. Similarly, you can write it for dou by dou y of y by r power 3 is equal to r cube minus 3y square r by r power 6, and dou by dou z of z by r cube will be equivalent to r cube minus 3z square r divided by r to the power 6. Therefore, del dot product of r vector by r cube, which is nothing but addition of all these three terms, that is nothing but 3r cube minus, in all these three things 3r will be common. So this will give you x square plus y square plus z square fully divided by r to the power 6. So this is 3r cube minus 3r into r square divided by r power 6. So that is nothing but 3r cube minus 3r cube by r power 6, which is equivalent to 0. So since del dot r vector divided by r cube equal to 0 implies it is solenoidal. Okay. So whenever the dot product is 0, it means that it is solenoidal. Now we will move on to the next problem. Show that r to the power alpha r vector is any irrotational vector for any value of alpha, but is solenoidal if alpha plus 3 equal to 0. And r vector is nothing but xi vector plus yj vector plus zk vector. So now we need to find del cross product of r to the power alpha into r vector. So first let us simplify what is this r power alpha into r vector. So this is nothing but r power alpha into x I vector plus r power alpha y j vector plus r to the power alpha into z k vector. Right? So now let us find what is del cross of this r power alpha into r vector. So this is nothing but determinant I vector, j vector, k vector, and the component of del, that is dou by dou x, dou by dou y, dou by dou z, then the component of r alpha into r vector, that is r to the power alpha into x, r to the power alpha into y, then r to the power alpha into z. So this is equivalent to I vector times dou by dou y of r to the power alpha into z minus dou by dou z of r to the power alpha into y, then minus j vector times dou by dou x of r to the power alpha into z minus this j vector times dou by dou x of this term minus dou by dou z of r to the power alpha into x, then plus k vector times dou by dou x of r to the power alpha into y minus dou by dou y of r to the power alpha into x. So this will be equivalent to, what is r to the power alpha? See, consider this r to the power alpha. R to the power alpha is nothing but, r is nothing but x square plus y square plus z square to the power 1 by 2. So this is nothing but alpha by 2. So when you differentiate the first term, so this is equivalent to I vector times, when you differentiate the first term with respect to y, you will get alpha by 2 times of x square plus y square plus z square into alpha by 2 minus 1. Okay, our differentiation is with respect to y. So when you differentiate the term which is there in the bracket, that will give you 2y, and already we have a z term over here. Let me bring it to the front. Okay, then minus, and for the differentiation for the second term will be y will remain as it is, and the differentiation of this r power alpha will be alpha by 2 x square plus y square plus z square to the power alpha by 2 minus 1 into and the differentiation for the terms is there inside the bracket is, here the differentiation is with respect to z, so this will be 2z. Okay, so let me write everything in terms of summation so that I did not write each and every step. So here this is 2yz alpha by 2 and here also 2yz alpha by 2, the same term. So this is going to be 0 times I vector plus 0 times minus 0 times j vector, and so here this is minus 0 j vector and plus 0 k vector. Therefore, this is going to give you the answer as 0 vector, which implies del cross of r to the power alpha into r vector equal to 0 vector, that is, it is irrotational. So now let us find del dot of r to the power alpha into r vector. So by the definition, it is dou by dou x of I vector plus dou by dou y j vector plus dou by dou z k vector dot product with r power alpha into xi vector plus yj vector plus zk vector. Okay. So now this is equivalent to dou by dou x of r to the power alpha into x plus dou by dou y of r to the power alpha into y plus dou by dou z r to the power alpha into z. So let us consider the first term, and then similarly we can do it for all the other terms. So this is dou by dou x of r to the power alpha into x. So here it is a product of two terms. So this is r to the power alpha, differentiation of x is nothing but 1, and let us retain x as it is, and the differentiation of r power alpha is alpha r to the power alpha minus 1, and the differentiation of r is dou r by dou x. So this is equivalent to r power alpha plus x alpha r to the power alpha minus 1, and dou r by dou x is nothing but x divided by r. So this is x by r. So this will give you r to the power alpha plus alpha r to the power alpha minus 2. Let me write this as minus 2 into x square. Similarly, you will be getting it for all the other terms. Therefore, del dot of r to the power alpha into r vector will be equivalent to r power alpha plus alpha r to the power alpha minus 2 into x square plus r to the power alpha plus alpha r alpha minus 2 into y square plus r to the power alpha plus alpha r to the power alpha minus 2 into z power 3. So this is for all the three terms. So here this is going to give you 3r power alpha plus, if we take alpha r to the power alpha minus 2 as common, here it is 2. Okay. So as common, the remaining will be x square plus y square plus z square. So this is equivalent to 3r power alpha plus alpha r alpha minus 2 into r square. So this will give you 3r to the power alpha plus alpha into r to the power alpha. So when you take this r power alpha common, you will get 3 plus alpha. So if this alpha plus 3 equivalent to 0, this divergence will become irrotational. Therefore, if we choose alpha plus 3 equal to 0, we get r dot of alpha dot of dot product with r to the power alpha into r vector is equivalent to 0, which implies it is solenoidal. Okay, so I will stop with this.